today's notes are introducing a strategy called synthetic long division, and this is kind of like an alternative to long division. So we just talked about polynomial long division, and this is kind of like an alternative. It's also could be considered a little bit of a shortcut. And for the purposes of today, it's going to seem kind of like magic because we're not really going to think too much about why it's working, but more just about the process. Okay, so just kind of focus on the process as opposed to kind of like the deeper understanding of why it works. And then later in the class, we're going to think a little bit more deeply about why synthetic division actually works and how it relates to polynomial long division. But for our purposes today, we're just focusing on process. And for this process, the first thing you're going to do, before I actually begin, I want to say this only works when your denominator, or what you're dividing by, is x plus or minus a number. So you can't have what you're dividing by have any exponents higher than 1, so it can only have an x to the first power, and then you can't have any coefficient in front of x. But as long as that's the case, synthetic division works. And what we're going to do is we're going to scoop up each of the coefficients from our numerator. So the first coefficient is a 3, so I'm going to write a 3. I'm going to try to use a lot of different colors here to try to emphasize what's going on. The next coefficient is a 4, so I'm going to write a 4. Next up, we have a negative 2. Make sure you bring the negative sign along with it. And then lastly, we have a negative 1. And now we kind of set up this little bar, which is our synthetic division bar. And I'm intentionally leaving some space underneath my numbers because I'm going to write another row of numbers there. Okay. And now to the left of my synthetic division bar, I'm going to put the constant term from the bottom. So that plus 4 is going to become a part of what I'm doing. But I'm going to take, let me fix what I just did. So instead of taking a plus 4, I'm going to take a negative 4. So whatever sign I see in front of the number, I'm going to do the opposite sign. So I'm taking the opposite sign. In this case, it was positive 4, so I'm going to write a negative 4. Okay, so now we're ready to begin the process. The first thing we're going to do is take the starting from left to right. So we're starting with the 3. The 3 actually just gets brought straight down below the bar. And now I'm going to take that 3 and multiply it by the negative 4. And that's what I'm going to write in this new spot right here. So 3 times negative 4 is negative 12. Okay, and now I'm going to take the sum of negative 12 and the number directly above it. So in this case, that would be the 4. So I'm doing 4 plus negative 12, and that would give me negative 8, right? So now I'm going to take negative 8 and multiply it by the negative 4 along the outside. So negative 4 times negative 8, negative times negative would give me positive 32. And I'm going to add 32 plus the negative 2 to get me a positive 30. And now I'm again going to multiply the 30 by the negative 4. And that would be negative 120. And my last step is to add the negative 120 with the negative 1 right above it, which would be a negative 121. Okay, and this is going to give us our final answer. So the negative 121, whatever's in that last spot, that we're going to kind of pull off to the side. That's going to be our remainder. So if there's nothing there, it means that it divided evenly and there is no remainder. So if you get like a 0 there. Okay? And then the 3 other numbers we see are going to be the coefficients of the other terms. And we're going to think the 30, the one on the far right, that's not the remainder, that's our constant, or that's like our x to the 0 term. Then moving towards the left, the negative 8 would be the x term, and the 3 would be the x squared. So if there was more numbers along the bottom, it just means we'd go higher than x squared. We get an x to the third and x to the fourth. So now, to write my final answer, I just have to put this all together. So it would be, in this case, we would have as our answer 3x to the third. So I'm putting together the 3 and the x, oh sorry, not x to the third, x to the second. Then negative 8x, then plus 30, and it's an x to the 0, so I'm not even going to write anything. Now to represent the remainder, I'm going to do the negative 121 divided by the original x plus 4, right? What we're dividing by to begin with. And that would be my final answer. So let's look at one more example to try to solidify this process, and then I'll give you some to try yourself. Okay, so in this next example, we have 2x to the fifth minus x to the third plus 3x squared minus 2x plus 7, all divided by x minus 3. So I'm going to start by pulling the coefficients. So I'm going to start with a 2 this time. Now, if you notice, I'm skipping from x to the fifth to x to the third, and there is no x to the fourth term, but when I go to do synthetic division, I need to somehow represent that there is no x to the fourth term. So I'm going to do that by putting a 0, because that's like there's a 0 x to the fourth that we just don't see there. It's invisible. So then the next term would be the minus 1 from my negative 1 x to the third. Next we have a plus 3. No, I'm not going to put the plus sign. I'm just going to write just a 3. Next we have a negative 2. And finally, we have a positive 7. So now I'm drawing my synthetic division bar, and I'm taking the negative 3, and because it's negative, I'm going to do the opposite sign of it when I go to set up my synthetic division, so I'm putting a positive 3. Okay, so now let's begin the process. I'm going to bring down the 2, and now I'm going to multiply the 2 by the 3 out front. And that's going to give me 2 times 3, 6. Now I'm doing 6 plus the 0 right above it, and that would give me 6. Take the 6, multiply it by the 3 out front, and get 18. 18 plus the negative 1 above it is 17. Now I'm taking 17 and multiplying it by 3, and that is 51. Now 51 plus the 3 right above it is 54. Now I'm doing 54 times 3. My numbers are getting bigger, but that is okay. 54 times 3 is 162. 162 plus negative 2 would be 160. And 160 times 3 is 480. 480 plus 7 is 487. Now that 487 is my remainder. I can think of the 160 as like my x to the 0, then my x term, x squared, x to the third, and x to the fourth. So when I go to write my final answer, I'm going to have 2x to the fourth plus 6 x to the third plus 17 x squared plus 54x plus 160, and then I have my remainder, 487, divided by the original x minus 3. And that would be my final answer from this synthetic division problem. So now I have 2 problems for you to try. And don't forget, in the second, part B problem to try, that we're missing an x to the 4th term. So remember what to do in that case. You're going to need to put a placeholder 0 when you set up your synthetic division problem. So we will be practicing this tomorrow, and you can ask me any questions. I just noticed a mistake I'm going to fix on this U-try problem, where I had a k where I should have had an x. Okay, so I will answer any questions about this process tomorrow, and we'll look into why it works as well.